is the basics. Let's get going. Oh, sorry, something else. For those students who are doing the weekend revision classes, I just wanted to mention the topics we'll be doing will be general algebra, including nature of the roots, some trig graphs, and if time allows, circle geometry. But what I want to encourage those of you who are doing this is please try and do some pre-work, because depending on how much pre-work you've done, it kind of affects, I don't want to go too fast or too slow, but if you've looked at the questions before we get there, it really helps with understanding. And so we will send you some pre-work for that Saturday workshop from 3 to 4:30. Now, I know it's only like some of you, so I don't want to spend too much time on it, but I know a lot of students were asking that. And so that's just to let you know. And then what are we doing today? So the guiding questions for today are the following. How do you prove lines are perpendicular, which we saw in the last lesson? And I'd love someone to put this in the chat, or if you're willing to put your hand up and tell us, I'd love to hear your voice. How do we prove lines are perpendicular? Who's feeling brave enough to share their... It's actually not that scary, guys, I promise. You can do it.
Let's go, guys.
Okay, so yeah, so gradients. Oh, Renee, let's hear from you. I'll unmute you.
To find the perpendicular is when you multiply the two gradients you find, and the answer has to equate to -1.
Okay, that's fantastic. If I told you that one of the gradients was -4, and the other line was perpendicular, what would the other gradient have to be? I'm being a bit sneaky here, but what would, if you knew that these two lines were perpendicular and the one gradient was -4, do you know what the other gradient would be? Am I being a little bit sneaky here? So what I was also wanting to kind of point out to everyone is that the product of the gradients are -1, but if you have one of the lines and you know they're perpendicular, then if you've got -4 over 1, then a line that is perpendicular to that is going to have the gradient 1 over 4 positive. You just flip them over and change the sign. Okay, so that's something to bear in mind. But thank you so much, Renee. That was fantastic to hear some voices. Now, my next question is, how do you prove something is a particular type of triangle or quadrilateral? So in today's lesson, we may have to do some stuff where we have to prove, like say a shape. We might have a shape that's got, they give us the coordinates, and we need to prove something is a particular type of triangle. I want to know, does anybody know how we would prove something's isosceles triangle, for example, or if it's a right angle triangle, what tools would we have to use? Anybody want to put something in the chat or raise their hand and tell us? Or anything that they know about. Like if I gave you a triangle and I gave you the points on the triangle, how would I figure out what sort of triangle? Yes, the distance formula. So for triangles, the distance formula would be a very good idea, because if, for example, I measured this and I worked out that, say, for example, this was 6, this was 6, this was 6, what type of triangle have I found? What type of triangle do I have? Yeah, it's an equilateral triangle, right? Exactly.
Ooh, this class is on fire today.
On fire. But if the triangle was like that, and I'm just making up numbers now, and I used the distance formula and I found that, what type of triangle would that be? Okay, isosceles, perfect. All right, so you can see how the distance formula is helpful. Ooh. However, what if we needed to prove a triangle what was 90 degrees? So a right angle triangle. How could we prove something is a right angle triangle? What are some of the techniques? If you think about the section, what are some of the techniques we could use if we wanted to show pop it in the chat if you think you know, or raise your hand if you feel like you. So the angle should be 90. Now, another word for 90 is also perpendicular, isn't it? So one person has said you could use Pythagoras. And guys, you totally could use Pythagoras. If you knew the lengths, it's actually called converse Pythagoras, you could use. But I'm looking for the quickest way, the quickest possible way of figuring out whether or not an angle is 90 degrees. What formula do we think? And if we think of 90 degrees as being perpendicular, what formula do we know proves something is at 90 degrees? What process? If I found the, yes, well done. If you find the gradient of BC and you find the gradient of AB, and when you multiply them together, you get -1. Well, what you've shown is that those two lines, so like there's one and there's another, you've shown that they must meet at 90. And so a lot of tonight is going to be about showing you the quickest way to do something. It wouldn't be wrong to do Pythagoras, but if you did Pythagoras, you'd have to do the distance formula first and then do Pythagoras, whereas this is super quick. If you understand why this is super quick, will you give us a thumbs up in the chat? I just want to check, because doing it efficiently is a big part of tonight's lesson. And so I'm trying to show you the quickest tool for showing something's 90 degrees. Okay, fantastic. That's awesome. Now, I will talk more about quadrilaterals later in the lesson, but I want to know if I wanted to prove, let's say I have 4 points and I want to show, let's say, for example, I want to prove that these 4 points maybe prove that it's parallel. What tools or techniques could we maybe use? And again, I'll explain it properly later in the lesson. I'm just giving you a little warm up. What do you think we maybe could use to prove something's a parallelogram? If I've got 4 points. Okay, so the one way, okay, you guys have obviously been learning this section. So it's not obvious, but you can points, yes. But when you say the midpoints, you mean the midpoints of what we call the diagonals. So if we have a parallelogram, we need to make sure that today we're going to talk about, sometimes we're going to talk about the sides, like these are the sides, but then the lines that go from A to C and B to D, those are called the diagonals. Okay, so the obvious way that I was thinking of was if you work out the gradient over here and the gradient over here, and you show the gradients are the same, then you know they're parallel. And you know that for a parallelogram, you would just have to do that twice. So that's one way of proving a parallelogram. The other way, though, and this is what I'm going to show you today, is that if you can show they're in half, you can also show something as a parallelogram by using the midpoints. So when you're proving something's a parallelogram, two choices. The one is the midpoints lesson. But I just wanted to start the lesson by just putting a little bit up front. Like, if you want to work out if something is a particular quadrilateral, how do we link it? And so that's kind of what I wanted to get your brains turning. Okay, but before we do that, I want us to go back to the last lesson. And I want us to see if we can do this question. So this is a straight follow-up from the last lesson. And the question says, there's a line. and the line is in this format. And and it asks you determine, find out if the line in green is perpendicular to the line that goes through here. And I want you to try and work out for me now whether or not you think it's perpendicular. And I'm going to give you 2 minutes to do that. This is straight revision from last time. And I want you to especially think about how do you prove perpendicular? Yes, let's do it. Let's do it.
Let's do this. Guys, remember to write it on your book. Like this, when we do corrections, you can correct and then see your mistake and then ask the question if you don't understand where did you go wrong. So it's very important.
Yeah. And I also want to think about this line in green. Like, what do we need to do with it? It's like, it looks okay, but it could look better. That's kind of what I want to say. So we have some people making some claims. How do you, for those who are making claims, how do you know that your claims are true? I want you to put in the chat. What evidence do you have that these are not perpendicular? Okay. And so okay, so a lot of students are making some claims, but I haven't done this question before, so I don't know what the answer is yet. But I know that I need the gradient of each of these lines. If I want to determine if it's perpendicular, I need the gradient. And so all I've done to start with is I've started by working out putting the line in standard form, and then the number in front of the x is the gradient. But I still need to work out the gradient of the other line. So that is going to be 4 minus 5. So 4 minus 5, and then 4 minus 2, which gives me minus 1 over 2. Aha. Now, what does that mean about these two gradients? Well, to me, it looks like they're equal. Now, what I was hoping for to prove, if lines are perpendicular, when you multiply them together, so let's multiply them together, I get a quarter. And because the gradients don't multiply to give you minus 1, it's not perpendicular. Okay, so lines not perpendicular because they don't multiply because the gradients, I'll say, gradient, because they don't multiply to minus 1. However, we do actually know something about their relationships. What is the relationship between these two lines? Oh, apparently you beat me to it. Jermaine, you beat me to it. If the gradients are the same, it means they are parallel. And so we haven't been able to prove they're perpendicular, but by the way, they're parallel. Okay, perfect. And I think what you're doing is you're starting to see how the old stuff we did before can always come back and help us. Okay, give us a thumbs up if you're feeling comfortable with that question. Give us a thumbs down if you're not feeling good with this question. Just want a quick feel for the class. Okay, so those who are struggling, just keep practicing, and also remember there are recordings of this thing. Okay, now this next question. Show that this triangle below, well, it says below, but it means above. I want you to work out or show me that this triangle is right angled. So I want you to think about, how do I show that a triangle is right angled? What evidence do I need And what tools do I need? So I'm going to put you, what tools do you need for the job? And what evidence do you need? Sound like a lawyer, don't I? Okay. If you want to give some hints in the chat, go ahead and give some hints, in terms of like those, we're helping each other. But I want to mainly let you try and do this by yourself. I want you to prove to me that the triangle PQR is right angles. Yes, Kidibona, I think you are on the right track. Yes, that is what the evidence that you need. Now go and get me the evidence. Gradient is definitely the tool that you need. Guys, I think you're getting this. Yeah. Okay, I'm going to let you shine brightly because you've got this.
Ah, well done, awesome people. Well done.
Okay. So QR and let's do this, guys. Let's do this.
We're finding the gradient, right?
Yeah. So whenever I use maybe I'll explain. So the M, the big M means the gradient. And so the QR means the segment of the line that I'm trying to work it out for. Now I'm thinking those two lines are the ones that would be perpendicular from the drawing. However, if they don't work, I could always try and work out the gradient of this line too. But for now, I'm going to guess that the drawing is somewhat accurate. So QR, so I'm going to go. And let's see if once you have your verdict, please do pop it in the chat. What am I doing? I'm saying I need to always watch that I don't make a silly mistake with the X's and the Y's. Oh, doesn't matter how good you are at this, they sneak up on you. Minus 1. So what do we think? We'll wait a little bit longer. Is this a right angled triangle or not? Siabonga? Yep. Why do you think it's a right angled triangle? Lesejo, also, you think it's a right angled triangle? So we'll say PQR is right angled. But now, guys, what we need to do is actually give a reason. And I've been a little bit slack in writing the reasons out perfectly. So what is the evidence that convinces us that it's right angled? Well, we know the gradient QR was 1 and the gradient of PQ was -1. And when we multiplied them together, we got -1, which is the evidence we were looking for. And when I say right angled, you could also, right angled is a synonym for perpendicular. They mean the same thing. Okay, I think you guys have done really well. And I think I want to go on to another type of question where we deal with quadrilaterals. Yeah, non-play, it would be fine. Yeah, that would be fine. Okay, so what I want to do now is I want to move to that different type of question that I spoke to you about. And there are two ways of, so basically here's a typical exam question. You're given 4 points and it says, show that ACER is a parallelogram. Now, one of the ways of doing it is to work out the gradients of that one and that one, and work out the gradient of that one and that one. If they're the same, you've proved it's a parallelogram because you have two parallel sides. However, everyone could do that, but it's not the quickest way to do it. The quickest way to prove something's a parallelogram, but what I would say, guys, is if you're in an exam and you're stuck and you don't know any other way, do it with gradients, not a problem at all. But the quickest way to do it is to prove that the diagonals bisect each other. Now, if you look at this, you can clearly see the diagonals are not the same length each other, but bisect, they don't need to be equal length. What bisect means, it means they cut each other in half. So the green one gets cut in half by the blue one, and the blue one gets cut in half by the green one. And the way we show that is we show that both diagonals have a common midpoint. So the midpoint of the green one is the same as the midpoint of the blue one. So what I want you to do for me is I want you to work out the midpoint. Notice I'm writing midpoint because if I wrote M, it would be confusing. I want you to find me the midpoint of AE, and I want you guys to find me the midpoint of RC. And I want you to just work this out first and see what you get. So over to you guys.
Guys, you're doing really well. I'm so impressed. I was so worried and be like, oh, it's gonna be so hard. And now you guys are just nailing every single question. Oh.
It's sometimes difficult to judge. I feel like I'm getting better at judging, but it definitely takes time to kind of feel where students are doing well and what sections they find tough, especially in this medium. But like anything, the more you practice, I think the more you kind of get better at something, I guess.
Renee has a question.
Go ahead, Renee. Maybe we could unmute. You can ask a question. Oh, yeah,
hi, sir. It's just a question for point E. Is that -3 to -2 or -3 to +2?
This E, this point over here is -3, -2.
All right, so, thank you, sir. I couldn't see through the line.
No problem at all. Maybe make it a little bit bigger. Cool.
Wow, answers already.
Are they coming in already?
Wow.
A. So for those who've forgotten how the midpoint formula works, just in case, because I think I did for a second, you add the two x's together, divide by 2, and then add the two y's together and divide by 2. So let's see what we get. So -3. What do I get? Oh, wait, no. Okay, I'll give that a bit of time still. I think students need a bit more time. Let me try and find the chat block. So once you have got your midpoint, just see what stands out about them. Just compare them and see what you get. -3 + 4 is 1/2, and that's 0. So I think that's that one. And then I need RC.
Guys, remember, if you do get confused and you didn't get this right, please do ask and see where you got it wrong so you can ask your questions. But well done. I see that we're getting the same answer as Teacher Peter. Well done, guys.
Okay. So I think it seems like everybody's getting that the midpoint of AE is a half naught. And the midpoint of RC is a half naught. So what does that actually mean? It means that ACER is a parallelogram. And why is it? It's a parallelogram because the diagonals bisect each other, and you have shown that there are common midpoints. The diagonals bisect because there's common midpoints. Okay, so that is the quickest way to show something as a parallelogram. Now, I think we need to practice that one more time before we have our break. But the good news is, look, okay, you could have done it the other way. It's just that the midpoint formula is the simplest formula. And so I encourage students to use it where you can. Okay, let's do another one.
I might say that the reasoning got me there because I have a tendency of just writing my answer and then I don't put my reasoning.
Yeah,
so
reasoning
important.
Yeah, and there are extra marks allocated so for giving that reasoning. So the evidence, and then that idea is important. Okay, so what do you have to do in this one? I want you to try and prove to me that ABCD is a parallelogram. And I want you to notice something else, guys, is that whenever we write down the letters of the parallelogram, we always tend to do it in an order where it's unbroken. So look, I mean, I know it's obvious, A, B, C, D, but if you moved around the parallelogram, the order is preserved. Okay, so that's something to bear in mind. Okay, but over to you guys. Prove to me A, B, C, D is a parallelogram. Don't worry, Muzi. If you've missed something a lot, the recording comes out quite soon. And then, Susanna, H is not the midpoint of AB. So H is another point. I took this from part of a question. I'll talk to you about H in a second. But for now, I want you to focus on, based on the last thing, you want to find the midpoint of that diagonal. And you also want to find the midpoint of that diagonal. And if they cut each other in half, then I suspect you're onto something. Okay. All right.
We can do this, guys. Let's go.
I also like to write down, I almost like to write down my structure of my argument before I go. So I write down, okay, I'm going to do this. I'm going to do that before I even get going.
It's helpful. Very helpful.
Yeah.
Oh, on fire, Jermaine. Yo.
Let's see, midpoint. I haven't got there yet. Well, 2 and then 2 plus minus. Oh, am I adding the right here? I am.
You guys are awesome. Oh, loving this class.
It's funny how when your brain goes between the gradient formula and the midpoint formula, you have to do those subtle adjustments just to remember, okay, what X, Y, Y, and then, the ones are minus, the other ones are plus.
Yeah, I also did that. For a second, I did that.
So what do we get? We get 2 over 2 and 0/2, which is the same as 1, 0. Okay. So I think that that most students seem to be getting the midpoint of 1, 0 for AC, and they also seem to be getting the midpoint of BD as 1, 0. So therefore, ABCD is a parallelogram. And why is that? Because the diagonals bisect, and you've shown that from common midpoints. Sorry, guys, it's getting a little bit messy there. So diagonals bisect common midpoints, and we've shown it's a parallelogram. Okay, before we take our little break, if you feel comfortable with this method, give us a thumbs up. If you feel like you haven't quite got figuring out the parallelogram down yet, give us a thumbs down. And I don't want to move on after the break until everyone is comfortable, and then I can build on this. Okay, fantastic. Okay, guys, it is time for a brain break. And I know that what you really want is one of these mystery questions. So let me find a brain break. So it's a Halloween theme. And so just take a moment to enjoy the pumpkin. I don't even know what that funny little green thing is. Caterpillar, gnome, anyway. And what I'm interested in knowing from you today, let your brain just wander for a second. What's a pumpkin plus a bat times, I don't even know if it's like is it a frog? A frog on a broomstick? What is that going to be? I think that's probably what it is. See if you can.
Leanne, this is the lizard.
It's a lizard. It's a lizard. Guys, my words sometimes fail me. It's a lizard on a broomstick. It's pretty cool. Like, I feel like the lizard would be good in a like its own animated TV show. Like, I don't know. Maybe it's just me, but
let's go, guys. Leander gave us a clue. A lizard is 10.
Okay. So the lizard is, what is it going to be? 10, 10, yes, because that's the only way you're going to get to 30. And so all my lizards, because they're a lizard, they must be worth 10. Be careful with the bats because there's 2 of them in a position. And I know before we had problems with those types of situations. So what do we have? So we have 10. Okay, our pumpkin must be 5.
Mm.
So has anybody got the answer yet? So pumpkins are 5. Now, because there's 2 bats here, this is going to be 1, 1, 1, 1. So who's got the final answer there? Okay, but because of BODMAS, be careful, guys. The BODMAS is going to catch you. So when you've got a plus and a times, which one gets executed first? Be careful. Aha. So in the land of BODMAS, division and multiplication comes before addition. And so the bat and the lizard are going to meet before the pumpkin, which means that I get 10 and 5. And so my final answer is 15.
Yeah,
Yes.
well done.
Okay, so it just shows you, hey, like BODMAS, it comes back to haunt you. Wherever you are, it's going to find you.
Yep.
So I hope you guys enjoyed that. Okay, I'm not going to make you stand up today, but what I will say is, well, I'm not going to do anything crazy, but don't be afraid to stand up and just have a quick stretch, because I know we've been going for a while and our brains need oxygen. So if you need to, just take a moment, stand up, stretch. Oh, my neck just clicked. And just have a little stretch before we carry on. Okay, so let's do the next part. So I want you to do this question for me. This is an old exam question. And I want you to just do, first of all, you have to show that AC is perpendicular to BD. So I want you to work that out whatever way you can. And then I want you to work out, show that AC bisects BD, which I think you'll have an idea of from earlier on. And then once you've done that, I want you to think what type of, quadrilateral is this? Okay, or how can we know that based on that information? Okay. But first of all, everybody, you're going to work out this bit, these two first, and then we'll talk from there. So over to you guys. How would you do that? If you want, you can give us hints in the chat. For those who are feeling confident, give us a hint of how you'd solve it. But I don't want to steal the challenge from you.
Let's do this, guys. Remember, it's 9 marks on the box. Let's do this, guys.
Cool. Yes. So I would recommend the first one, you use gradient. In order to show something's perpendicular, the quickest way to show it's perpendicular is gradient. And so my recommendation is gradient. To show that AC bisects BD, these are diagonals, right? You can see on the drawing. And so I would use the midpoint here. But that's just the tool. Now you need to go find me the evidence, right? So it's one thing to know what tool to take out of your tool bag. It's another thing to actually use it properly. So let's see if you can use it properly.
Let's do this, guys. Come on, let's do it. Woo! Let's see.
So how do you find what the gradient? Yeah, I do. I really like writing down my plan first. It makes me feel organized. So Jermaine, you are, interesting. Okay. So some students are claiming they know what the quadrilateral is. We'll come to the evidence in a moment, but for now, let's just make sure our evidence is valid. But I think you're on the right track, Jermaine. Okay, I need to work up my gradients before I can make any claims and make sure I don't make a silly mistake. So I'm going to go 1 minus 7 and then 0 minus 2, get minus 6 of minus 2, which is positive 3, which is good news. So I have proved AC perpendicular to BD, and sometimes what students just write for the reason is they just literally say, what are the gradients there? When you multiply them, you get -1. So yeah, 2.2.1 is perpendicular because when you multiply the gradients, and these are the two gradients, they're not equal, which is good news. When you multiply them together, you will get -1. Okay, does AC bisect BD? Okay, does AC bisect BD?
Guys, I'm sure you marking and we got 3 out of 3. If you didn't, look, still you can ask your question if you didn't see your mistake, but well done to everybody who tried this question.
Yeah. I can see on the cameras, everybody seems they're working hard, and that's what we want. We want students to have a chance to practice in the lesson. So what is A and C? So I've got Is that going to give me? So you should get. Okay, so I'm going to watch the chat for answers. Is everybody getting a midpoint of that? Okay. Now, okay, you are. All right. So what does this mean? So let's just take a moment and check the evidence. So at the moment, what we see is that we know that they have common midpoints. So the green thing tells us it's a parallelogram. But what does it mean? So what does it mean when the diagonals, it's not just, so basically before what we did was, oh, sorry guys, these are huge. I need to find something which is a bit shorter. Before what we did was we found the common midpoint. We found the midpoint of BD. We found the midpoint of AC, and we said, cool, there's a common midpoint, it's a parallelogram. But what does it mean when AC is perpendicular to BD? Because that's an additional condition. Does anybody know what that means about the parallelogram? So if you have a parallelogram, a special type of parallelogram, where the diagonals cut each other at 90 degrees, what is that called? It is right angled, yes, but it's got a special name. It's called a rhombus. Yes. So if you want to prove that a quadrilateral is a rhombus, not only do you have to show that the diagonals bisect each other, you have to show that they bisect each other at 90. And so the reason, I'm running out of space here, but the reason that you would write is you'd say it's a rhombus, or at least if you stopped at this point, you'd say that it's a rhombus because the diagonals, apologies, the diagonals bisect at 90 degrees. So what that means is they cut each other in half, but when they do it, they cut each other at half at 90 degrees. All right. Now, that is how you would prove a rhombus. Now, it may be possible that it's even more specialized shape, but we're not going to go into that tonight. What I really want you to take away is, how do you prove it's a parallelogram? You look for common midpoints. How do you prove it's a rhombus? You show common midpoints and the diagonals cut each other at 90 degrees or are perpendicular. And what we're doing then is your toolkit, you know that to work out what quadrilaterals are, you're often going to be using the midpoint formula and the gradient formula. Okay, give me a thumbs up if you followed my I want to do one more question tonight like this. Is everybody following my argument? It's common midpoints for parallelogram. It's diagonals at 90 degrees to make it a rhombus. And a rhombus, guys, is a special type of parallelogram. It's a parallelogram where all the outside sides are equal. Now, I'm not going to go into detail about, because basically a rhombus is like a square that's been put on its side. Now, it does raise the question, how would you know if this is a square and a rectangle, which I will try and get to in the remaining time. But for now, I just want you to look at this thing, and I want you to prove to me, show me that ABCD is a rhombus. So do that for me now. This is an exam question. I think it would normally be worth more than 3 marks though. Normally be worth about 5 or 6. But to finish today, let's try and prove ABCD is a parallelogram. Over to you guys.
Let's do it, guys. Look, you've already impressed me, so I know this is gonna be a piece of cake. Let's do it.
So how can you prove that the diagonals bisect at 90? Is there a method? Okay, yes, there is, Dawn. So what you first do when you're proving a rhombus is you first prove it's a parallelogram. And the way we did that was to find common midpoints on the diagonals. So basically, and when I say common midpoints, what I'm saying is that the diagonals cut each other in half, or we say the fancy word is the diagonals bisect. So in this scenario, we want to show the diagonals are not equal in length necessarily, but we first show that there's a common midpoint for both diagonals. Now, to show that those diagonals meet at 90, what I need to use is I need to show that the gradients, I need to find the gradient of AC and find the gradient of BD. And if when I multiply them, they give me a particular number, it means the diagonals are at 90. Does that help a little bit, Dawn? I don't know if, basically there's two steps to show that they bisect at 90. The bisecting part is the midpoint, the 90 part is the gradient. That's the process that we need to follow. So okay, so there's 2, 22. So you know, at the end of the session, this is when I'm most likely to make a mistake. So bear that in mind with my negatives and my positives.
I'm watching.
Because sometimes your brain just goes into autopilot. Okay, so I think I'm getting some good news. Okay, some people are already making some claims. I need to still build my evidence base, so I'll give it a moment or two more because there's a lot of calculations to be done, and so I would imagine for everyone it's still gradient. Well, let's do AC first.
Guys, I just want to point out for those who haven't been seeing all the lessons about analytic geometry, remember that it's also on the website, so you can go there and watch it from the beginning until the end, because today is I believe is the last lesson on this topic. So you're allowed to go to the website and just watch it, okay? Because this will really, really help you. I've learned a lot. Thank you, Teacher Peter.
It's a pleasure. Oh, sorry, let me get this down here. So MBD, and we have 5 minus 3. And then we have -9 minus 7, which gives us 8 over -16, which gives us that. Okay, so it looks like the evidence is in, and I apologize if I've rushed you a little bit here, but what I'm seeing is that I have common midpoints, which means the diagonals bisect each other, and if I multiply -1/2 times 2, to me, that gives me -1. And so what I'm going to write is that this is a rhombus. A, B, C, D is a rhombus. And well, and the reason it's a rhombus is, I'm actually running out of space, so let me just use the writing there. A, B, C, D is a rhombus. And the reason it's a rhombus is the diagonals bisect at 90 degrees. The bisect part comes from the common midpoints in yellow, and then at 90 degrees, and actually what I should write, I'm being a little bit naughty, what I should write is I should write the evidence here, MBD times M of AC. When you multiply them together, you get -1. Now, actually, guys, there is an extra mark for writing that down. And so you do that. Then after you've written down that evidence, you can then say this thing is a rhombus. And then the final reason is this thing over here, the diagonals are bisecting at 90. All right, give us a thumbs up if you feel reasonably confident with this method. I know we've only done twice, but obviously you can practice it more yourself. Give us a thumbs down if you're still feeling uncertain. Okay. So guys, I'm going to then call it a thing for tonight. But what I want to do is I'd like Yolanda to get the link for the quiz ready. And then I'd also love for you guys to do the poll, just so we can get a sense of the pacing for the lesson. I love to get a sense of, because I don't have physical body language like I would in a normal classroom, always helpful to do a poll. And so if it's not too much trouble to ask, I would appreciate that greatly. Yolanda, anything
Thank you. Yeah, I've already posted the, so I keep on posting the link, guys, to the quiz. It's going to be about analytic geometry. You guys are gonna ace it either way, so I'm not even worried. Oh, you've proven me that you are capable of doing this. Well done, guys. I'm proud of everybody. Well
it did,
done.
Ivana. It went past very quickly because we were in that sweet spot, that spot where, you know, like you're just at the edge of your comfort zone, but you can keep learning.
Pushing,
and I think that's the goal for us, to just get in that sweet spot as much as we can. The next topic, Bokhlale, is number patterns. So we're going to do linear number patterns and then quadratic number patterns. And then after that, it's functions. So we're doing functions, and those are the two other topics that are coming up quite soon. And then we have our little bit of holiday workshops also. Next week, Monday, yep, that's when it's going to be happening. And number patterns. Yeah. Oh, thank you, Sepiso. I appreciate that.
It was a fun lesson. I agree with Sepiso.
All right. Then I'm going to send you on your way, guys, to go and do your quiz. And yeah, it was great teaching you tonight. And I hope that you have a fantastic quiz experience and that you keep practicing hard. I'll see some of you on Saturday also. And yeah.
Bye, guys. Good evening.
You will help tonight. I feel like we're also learning how to work together well now. And you know, it's like anything, it's like a partnership. You have to
finding a balance. Yeah.
Exactly. Yeah. So, same time next week, Monday. Yep. 6 o'clock on Monday.
They want to know what can they expect for the maths paper 1 exam. I guess this is on Saturday.
So it's going to be sent to you guys. So again, we're just doing some prep. At the beginning of the lesson, I said the weekend questions will do general algebra, and you will be sent those questions on Friday or maybe even tomorrow. And so it's good if you look at them a bit before the time. And then there'll be a bit on trig graphs and circle geometry if time allows. But the focus is more on paper 1 this week. It's a general algebra question. Okay, Susanna, I see you have a question. You want to unmute yourself? I'm going to try and unmute you. Yeah.
Sir?
Yes.
About the previous work we did.
Yeah.
If they asked us, prove that parallelogram or something, or shape something.
Yeah.
Is a parallelogram. Okay, this one. Prove that A, B, C, D is a parallelogram, but they hadn't given us the units for maybe D, and they said X and Y. How do we work that out?
Okay, so what you're talking about is the missing point question. And what you do in that scenario, so you're saying, look, there's no D, there's just an X and a Y there. Because a parallelogram has the property that the gradients are the same and the sides are the same, you need to ask yourself, how far across do I go to get to A, and how far up do I go? So Susanna, how to go from B to A, how far do I go across? From -9 to 2. Are you with me, Susanna? I don't know. So what I think you would see is that you go across by 11 units. So from -9 to +2, you go from -9 to 0 and then 2. So for me, this would be 11. And how much do I go up by? I go from 5 on the y-axis to 7. So I go up by 2. So if I was wanting to know what this point D was, I would do the same thing. I would go -4 plus 11 for the X. So I'd say, and then I'd say -5 plus 2. And so if I then work that out, -4 plus 11, I did it maybe a little bit quickly. Susanna, do you want to just see that you are following what I'm saying? So, but what if it was a 4 or 5 mark question? They wanted us to use the gradient or method. So it depends on the question. If they say do something, you have to follow their instructions. And so that would be the key. Whenever an exam says do something, round 2 decimal places or 1 decimal place, you follow whatever they say. But if they say prove it's a parallelogram, then you would just do it the simplest way possible. That would be my recommendation. So yeah, so I hope that little what I was saying, basically, if you have a missing point on a parallelogram, you say, look, to go from the one corner to the other, you ask yourself, how does X change? How does Y change? And then you do the same thing for this one. So you go across by 11 and you go up by 2. And that's why I was adding an 11 to the X and I was adding a 2 to the Y. Okay, so I hope that helps a little bit. All right. Let us call, I think it's time for us to wrap up the lesson, but thank you guys. It was really enjoyable and I could see you're working very hard. And so I can, as a teacher, I really can appreciate that and recognize that.